All right, today we're going to talk about a part of math that sounds super complicated, but is actually one of the most powerful tools ever invented for measuring the world. We're talking about trigonometry.
So, let's start with a puzzle. Picture this. You're standing in front of a giant tower. You can see the very top, but you have absolutely no way to get to it. How in the world do you figure out how tall that tower is without ever leaving the ground? Seems impossible, right? Well, not really, if you have the right tools.
And that's where trigonometry comes in. The name pretty much gives the game away. It's from two Greek words, trigonon, which means triangle, and metron, which means measure. So yeah, at its heart, trigonometry is just measuring triangles. And that simple idea is the secret to solving our tower puzzle.
To get going, we need to understand the parts of one very special shape, the right-angled triangle. This is where all the magic happens. Let's break down its three sides, but from the point of view of one of the angles.
Okay, first up, you've got the big one, the superstar of the triangle, the hypotenuse. It's always the longest side, and you can spot it in a second because it's always right across from that 90-degree corner. It's the one side that never changes its job.
Now, here's where it gets really clever. The opposite side, well, its identity actually changes depending on which angle you're looking from. It's always the side that's directly across from the angle you're focused on. It's all about your point of view.
And rounding out our trio is the adjacent side. Adjacent is just a fancy word for next to. This is the side that's touching the angle you're interested in. But, and this is key, it's not the hypotenuse. So there you have it, our three key players: hypotenuse, opposite, and adjacent. Now let's learn their secret language.
So what do we do with these sides? Well, mathematicians discovered something incredible. For any angle in a right-angle triangle, the ratio of its side lengths is always the same. They gave these special ratios names: sine, cosine, and tangent. And even better, they gave us a secret code to remember it all.
And that code is SOHCAHTOA. Say it a few times. SOHCAHTOA. It sounds a little weird, I know, but trust me, this is maybe the most useful little phrase in all of basic trigonometry. Let me show you what it means.
It's actually super simple. So tells us that sine equals opposite over hypotenuse. Ca means cosine equals adjacent over hypotenuse. And toa is tangent equals opposite over adjacent. That's it. That is the whole secret. And these three little formulas are all we need. All right, time for that aha moment. We've got our problem, we've got our tools. Let's put SOHCAHTOA into action and actually measure that impossible distance.
Okay, let's go back to our tower. Let's say we already know the tower's height is 20 meters. And from where we're standing, the angle when we look up to the top, that's called the angle of elevation, is exactly 30 degrees. So the tower's height is the side opposite our angle, right? And the distance along the ground we want to find, that's the side adjacent to our angle.
So, think about it. We know the opposite, and we need the adjacent. Which one of our cools, so, ca, or toa, is the one that connects those two? Yep, you got it. It's TOA. Tangent is the one that uses opposite and adjacent. We found the right key for this lock.
So now we just plug in the numbers. The tangent of our 30-degree angle equals the opposite side, which is 20, divided by the distance we don't know. Now the cool part is, we don't even have to calculate the tangent of 30 degrees. It's a known value. It's always 1 over the square root of 3. So we just swap that in, rearrange the equation a little bit, and solve for our mystery distance.
And there it is. The distance to the base of the tower is about 34.64 meters. And we did it all without a tape measure, without moving an inch. We just measured the impossible. How cool is that? But look, this isn't just a neat math trick for towers. Once you know about SOHCAHTOA, you start seeing that it is, quite literally, everywhere. It's kind of running the show behind the scenes of our modern world.
I mean, think about it. Look at a bridge or a skyscraper. What do you see? Triangles, thousands of them. Engineers are using these exact same principles to figure out all the angles and forces to make sure those massive structures don't fall down.
Now let's zoom out, like way, way out. How do we know how far away the stars are? You guessed it. Astronomers create a giant cosmic-sized triangle. They measure a star's position, wait 6 months for the Earth to travel to the other side of the sun, and measure it again. That tiny shift in angle lets them calculate the distance. The scale is insane, but the math is exactly the same.
And it just keeps going. The sound waves for the music you listen to, the light waves from the screen you're watching this on, they're all described by sine and cosine. It's used in video games, GPS, mapping, you name it. It's a fundamental part of how our world works.
And you know, SOHCAHTOA is really just the beginning. There are even deeper rules, like this one here. This is called an identity, and it shows this beautiful, perfect relationship between sine and cosine that is always true for any angle. It's these more advanced tools that let people solve incredibly complex problems.
So, at the end of the day, it all comes back to this one simple but incredibly powerful idea. If we understand the relationships inside a simple right-angled triangle, we can measure just about anything.
We just took what seemed like an impossible problem and turned it into a simple calculation. You now have the key to a whole new way of looking at the world. So the only question left is, what are you going to measure?